Welcome, everybody, to a fireside chat with myself and Snehal. We're going to start with introductions, I think, just to kick things off and make sure you know who you're talking to. Before I do introductions, I do want to just mention we have a question functionality on the side of the chat box there. If you have any questions as we go, this is meant to be a informal session. We want it to be a discussion if possible. So feel free to fire away with questions in there and we'll tackle them as we can throughout the discussion. But in terms of introductions, I'm Jordan LaRose. I'm the Director of Infrastructure Security here at NCC Group. And I'm joined today by Snehal, if you'd like to introduce yourself.
Yeah, Jordan, so great to catch up with you again. My name is Snehal Antani. I'm the co-founder and CEO here at Horizon3.
Awesome. Thank you, Snehal. So yeah, so this session, again, it's intended as a fireside chat. So we're going to address a bunch of the pre-submitted questions and then any questions that come up through the chat. And we'll just kind of be firing back and forth. So yeah, thanks for joining us and hope it's engaging. So let's start with, looks like we already have a chat question. And it's a pretty good one for you, Snehal, I think. From Sue, it's how can AI be used to assist cybersecurity?
So I think we'll both go back and forth on this one because I think we're both pragmatists, right? There's no immediate magic button of AI is going to fix everything. And so when I think about AI for cybersecurity, let's double click on two sides. The first one is the attack. There are two styles of AI architecture that have emerged. One style is basically iterative trial and error. So think of it as you ask a question, a prompt, the prompt doesn't really give you the exact answer you wanted, and you'll iterate and you'll iterate and you'll iterate. Eventually you get the prompt to get to the answer you're hoping to get to. And the issue with really large, unbounded, broad questions when you ask an LLM is those LLMs tend to wander. So you end up with lots of iterations. 1 iteration, 2 iterations, 15 iterations, or whatever it might be to get there. And that doesn't really work in pen testing, as an example, where you have to be very careful of every command you're running against a production system. On the flip side, there's structured reasoning. We'll talk about more with that architecture, but the net is AI has a ton of potential for cybersecurity, but there is no magic red button easy button that's going to solve everything. AI and LLMs in particular are really good at targeted, structured reasoning. Give it a very narrow question and a ton of context around that question, and you'll get back a fairly simple answer. But for AI to reason across multiple steps, multiple systems, multiple hops, the technology just isn't there yet. And by all accounts, it seems. So anyways, I talk about there's no magic easy button. AI today is not good at reasoning against large, unbounded problems. It's really good at answering very narrow, targeted questions. And so the role of AI in cybersecurity is if you give it a very narrow question with a ton of context, you're going to get a pretty high quality answer. If you ask it something very broad and generic, it's going to wander and drift. And so the answer is there's a ton of potential to assist attackers, to assist defenders, but in very narrow reasoning scenarios versus broad question scenarios.
Yeah, and I think there's a lot of practical examples of that in the industry over the years. Even I remember, you might not think it, but I've been in the industry for almost 15 years. And back when I started, I still remember using Markov-based decision models to conduct password guessing attacks. And it's pretty effective. We used it alongside like Hashcat and some other common tools. And, the Markov model in a lot of cases would actually perform better. But I think, to your point, Snehal, like that's a really narrow, specific use case. You're feeding it very specific information about the company and what you're trying to guess. And it goes in and it tackles that. Another example I wanted to bring up too is user behavior analytics for the blue teams. That's another example. It's maybe not AI in the traditional sense, right? The sense of LLMs today, but user behavior analytics, it's still something where you're using AI, or maybe not AI, but computer-based decision making to take a look at a huge subset of data, use a lot of different criteria that you have there, and then make a decision as to, hey, is this normal activity or is it not? And then again, it's giving the computer a really broad set of data, but asking it a very narrow question. Is this normal or is this not normal? Take a look at everything I've got and give me an answer. So it's interesting in that, AI is coming into the industry today because it's probably the biggest buzzword I think on the scene. I don't think it's controversial to say that, but it's something that's been around for a while, and we've used it in these narrow use cases in cybersecurity. It's just it's something now where we have a much more powerful suite of AI tools today than we ever did before. So I think it's about like finding those applications and making the best of it.
Yeah,
Would you agree?
here's an example of that. Sorry to cut you off. Is advanced data pilfering. So when you're a pen tester or hacker and you gain access to a shared drive that has 1 million files in it, somewhere in that shared drive could be really interesting, juicy data, intellectual property or a passwords file in sysvol or whatever else there might be. And you can't regex your way through that shared drive. There's just too many files. So what do? Well, you're going to try to guess and look at file types and so on, but you're still not going to be very thorough. And you're going to miss like a particular file could be CAD drawings for in an example recently, we found CAD file drawings for Nimitz class aircraft carriers and nuclear submarines tucked away in millions of files in a shared drive. So this is a great example of targeted reasoning or very narrow reasoning using LLMs. So if you've got 1 million files, you can't also just pass one file at a time to an LLM. It's going to take forever. And it's also very expensive because tokens for LLMs are quite expensive. So you do this blended approach of machine learning classifiers and LLMs. So you can train a classifier that basically says, do we think this file is interesting or not? Yes or no? And you're able to train that up on different file types, different keywords, different types of regulated data, other things like that. You can get a pretty good classifier whose sole job is to say, is interesting or not interesting. And then from there, if it's interesting, then you only pass the interesting files back to an LLM service that's going to try to reason over the contents and say, oh, this looks like the CFO's personal calendar, or this looks like the accounts receivables team's passwords or configurations or something to that effect. And in that scenario, you're now blending good old boring automation to enumerate the share drive with machine learning classifiers that are really easy to train and really cheap to run at the edge, with LLMs for using what they're really good at, which is reasoning over a narrow problem set. And now suddenly running into 1 million files or 10 million files on a share drive becomes actually a tractable problem for you to go and understand the business value that's tucked away within it. What's been your experience in doing things like that when you're pen testing and you come across a big trove of data and the role you've seen between machine learning, automation, regex, and LLMs could play in solving that problem?
Yeah, I mean, as a pen tester, I have so many stories where I've got 2 weeks or 3 weeks or whatever it is to test a network. I get to that inflection point where I have so many files and shares and things that I have access to, and like you said, prioritizing or finding the needle in the haystack there is not something that tooling or humans are really built to do. I've one particular example comes to mind where I managed to compromise like a pretty large scale like LDAP interface. It was large enough that LDAP search couldn't actually query the entire directory structure in one query. There were too many entries. That's one of the only times I've ever seen that. But in doing that, I had to find a way to try and figure out, okay, what information within this entire LDAP structure is interesting to me. And honestly, I found some interesting stuff. I showed the client, I said, hey, this seems pretty serious, but I don't know the extent of this vulnerability because I can't reasonably tell you everything that's in here. I tried a bunch of tooling and things and it helped a little bit, but it didn't get me there. This was probably 7 or 8 years ago. So way before we had access to anything like artificial intelligence. And I think if I had that capability at the time, I could have thrown all that, like all the results I was getting, I think the limits on LDAP search like 65535, right? So all of those entries I could have thrown into an LLM and said, hey, what looks interesting, or what should I be prioritizing here? And I bet you I would have found a hell of a lot more than I did on that engagement. So
That's
um,
it's a funny 65535. And in computer science, there are three numbers: 0, 1, and n. um,
yeah, it's the, or yeah, go ahead.
if you expand on this, there's another really interesting issue. So, game of Active Directory, we'd mentioned before this. Game of Active Directory is a pretty legit range. If you do Goad hard, where you've patched all the servers, you don't have any vulnerabilities pre 2025, you don't have any legacy protocols, you have Defender up and running. That's a pretty legit range for you to go off and
Yeah.
compromise as a pen tester. And what makes that range very difficult, or there are a few things. One is you have to be able to compromise machine, find something on that machine, and use it to progress your attack. So it's a multi-hop, multi-step attack paths. The second is you compromise trust, or gain access or abuse trust in one way. How do you follow that trust abuse to the next domain? And then the third is you've got to reason over file contents, whether it's a password in sysvol or a password that is part of the Active Directory parameters or attributes. And so these are things that you can't, once again, hard code or script or regex your way through. No automated solutions ever solved Goad before. You do have to be autonomous with this blend of targeted reasoning and other techniques in order to solve it. And so talk a bit about your experience solving those kinds of problems, because Node Zero was the first AI hacker to fully solve Goad. And we actually talked about that at Black Hat, which is really cool on stage. And Node Zero solved it in 14 minutes. And that's roughly, we think, about 50x faster than a human. And it's a really interesting breakthrough in this combination of very narrow targeted reasoning combined with machine learning, combined with automation in order to achieve that task. So talk about kind of your experiences there and what makes solving those kinds of systems really hard for AI.
Yeah, I know Goad is something that we use to train a lot of our pen testers actually at NCC. And yeah, at least a day, right, is what we usually give them for the exercise. Goad hard in particular is something that we use to, I would say when you're like a moderately skilled pen tester on internal networks, you tend to rely on things like Bloodhound a lot to get around in the Active Directory environment and kind of make sense of this huge ball of information that you have. And it's a useful tool, right? But if you just rely on Bloodhound to get around in the network, then you're missing a whole lot of potential, vectors, right? And you mentioned some of the ones that Bloodhound will not pick up on, which is like, sysvol credentials or something, hidden away in a file share somewhere. Bloodhound is just looking at trust relationships, really, and what users are logged into what machines, and kind of the I would say the quantifiable stuff. Those unquantifiable things are the things that we're kind of trying to teach when we put somebody through Goad on hard mode. So it's really interesting to see a tool like Node Zero go through and actually be able to do those, like how would I say, like the previously non-automatable parts of the challenge.
Yeah.
So I think it's a super powerful tool, and it's completely changed the game for us in terms of like how we think about or approach pen testing. Because before, we would say, okay, we're going to send in the manual tester to do this because we can't find a way through with Bloodhound, or we can't find a way through with any of these crawling scripts or whatever that we have. But something that's leveraging kind of all those best of breed tools and putting them together in a sensible way, I think that's really interesting.
Actually, let's double click on that, which is, in this new world, what is the role of the human in pen testing? What does human machine teaming like? And you guys are really leading the way in understanding that paradigm. And so what does human machine teaming in pen testing offensive cyber look like from your point of view?
So, it's no secret that we use Node Zero. In fact, I'm proud to say we use Node Zero because, we're we're not going to solve your version of Goad either in 14 minutes, right? So having a tool like that by our side is super, super useful. I think what the human can still do that the tool can't do, and it's kind of funny. It's like it reminds me of I don't know, some of those like futuristic movies from the 2000s where the only way to beat the AI or the automation is with more AI or automation, and that's kind of where we see the biggest gap still is like not just with Node Zero, but any fingerprintable tool, anything that's out of the box or identifiable. EDRs or antiviruses are keyed in to detect those things and really come in and kind of shoot them down. That's where you can add in the human entropy, I think, to get around that. I've seen Node Zero in a lot of instances on internal networks. It performs super well. It gets us farther in a day than we probably would have gotten in a week. But it'll hit a brick wall of a really nasty configuration of antivirus or an EDR that somebody's really tuned well. We can come in with our knowledge of, hey, I've avoided this thing 500 different ways. Let me figure out 501. And that human ingenuity in terms of evading that antivirus or bypassing that EDR. That's still, I think, really valuable and something that we always want in our kill chains. And there's also some there's vulnerabilities that you just can't anticipate that you'll find. Like sometimes they're O days, sometimes they're like essential O days, things like, if there's a bespoke protocol or maybe there's weird application or something that's got a business logic vulnerability. Those really creative vulnerabilities, I think, are still something that, the human element is great at. And what I love about using Node Zero is that it allows us to really focus on that stuff. It's the stuff that's always been fun in pen testing. It's the stuff that I've always looked forward to. But we've never really had the chance to focus on it because we were always stuck, doing the important stuff, basically, or the standard stuff, the stuff that you have to do on every pen test that, a tool like Node Zero is so well positioned for.
I think I kind of think about the art of the possible here in two different vectors. There's coverage and there's capability. And so the coverage problem, I think, is going to get solved pretty quickly over time, right? We add new TTPs, new protocol exploit tactics, new vulnerabilities or misconfigurations every day. And I think that that's just a matter of time. In fact, there's really interesting techniques to go off and continue to increase coverage of all the Metasploit modules. The problem with a lot of that stuff, though, is they weren't written to be safe to run against production systems. They tend to be coded by researchers that only coded for the happy path. So we actually have to spend a lot of time looking at and understanding every piece of exploit code and whether it's production safe or not, and then hardening it, which is quite a long pole in the tent. And so I view coverage as a solvable problem with time and labor. I view capability, though, as it's going to be quite a while before an AI hacker is capable of doing certain classes of problems. I think finding logic flaws in custom code is still a uniquely human problem to go solve. And even if you look at some of the model alloying and other techniques that have kind of emerged, and we can talk about that in a bit of whether those are even feasible against production systems, they're still looking at very basic, like cross-site scripting, request forgery type problems or so on. They're not really finding logic flaws in 0 days in custom code, whether it's your custom banking code or your payments code or so on. So I think that's an area where humans are uniquely gifted, that they're going to be able to make a really big dent. And the second area is a blend of capability and coverage, which is the long tail of OT and industrial control systems type environment. So for instance, in order for me to guarantee production safety, I need a cyber range that includes those artifacts in a myriad of configurations. So think of like vCenter. If we want to go off and claim production safety of our vCenter exploits and other tactics, not only do I need basically every version of vCenter with every minor patch available to me to test against, I also need every possible configuration that it could be in that would behave in different ways. So it is our cyber range in particular is an incredibly complex piece of capability within Horizon 3 in order for us to ensure production safety. I can't afford to buy a nuclear reactor or a power grid, right? So I don't have access to all of the gear and configurations needed for those OT systems to be attacked by Node Zero to ensure production safety. And so the finesse and cautiousness of a human, I think, allows humans to be very uniquely capable of solving those class of problems. So I think logic flaws in custom code, and the long tail of OT industrial control systems become two parts of the problem that are almost exclusively human. Whereas I think hybrid cloud infrastructure at scale and aspects of web app pen testing become uniquely algorithmic.
Yeah, it's interesting you bring up web app testing because it's an area that I've seen a lot of people starting to tackle with AI, and I do think there are parts of it that can be right. There's plenty of, again, I don't want to call them standard vulnerabilities, but kind of like vulnerabilities that I think are automatable, and some of them I've really sketchily automated myself in the past. Definitely nothing as mature as some of these products out there, but you brought up cross-site scripting, which is like it's a pet vulnerability for me in a way, but it brings to mind some of the cross-site scripting exploits that I've done over time that I could never see an AI doing because I feel like they were almost like unique to me. I remember one in particular. Some of you are probably going to retch at the thought of this tag, but I had a particular XSS filter that I was trying to bypass. It was really aggressive. It basically stopped any JavaScript event handler in any HTML tag. You couldn't call JavaScript at all basically against this filter. So I was thinking, okay, it knows every single filter it knows every single event handler, on load, on click, all of this stuff that it's standard to JavaScript and it's within this framework. I think it was actually part of React application, so it might be a React native filter. But I was like, all right, well, what hasn't React ever seen? Well, I bet you it hasn't seen marquee tags because marquee tags are something that should have died 20 years ago, but many modern browsers still support them. And if you go into your HTML console, you can still throw in a marquee tag in there if you want to. Wouldn't recommend it for the sake of your eyeballs, but marquee tags have a really unique element to them, which is on bounce. When it hits the side of the screen and bounce back, right? So I use that on bounce event handler alongside a bunch of other really hacky obfuscation stuff. And I finally bypassed this filter. It took me like 2 or 3 days to bypass the thing, but I had a vendetta against it at that point. And that's just the vulnerability that I feel like, I don't know, it was something like my crusty HTML knowledge as a previous developer combined with a bunch of evasion techniques that I had tried on different applications. Maybe we'll get there someday with AI, but I feel like right now that's something that you're really only going to see come out of a human brain, partially
Yeah.
because of how depraved it is.
So that triggers two interesting questions. But the first one is just I always see a lot of questions, whether it's on Reddit forums or I'll get fielded and so on. I'm sure you get them too, on what does it take to become a pen tester? Almost like a career and a career journey question. And one of the unique things I've noticed about people that are in offensive cyber generally, whether it's military, intelligence, or ethical hacking, is they are obsessed with mastering their craft. And it doesn't matter if they have a degree or not. What's unique about all of them is they're obsessed with, they eat, breathe, live, sleep this stuff. They, for fun, will go off and learn about legacy networking protocols, or they will have mastered Windows IT administration, or they will have remembered crusty old marquee tags in HTML. They are obsessed with mastering their craft. And I think in AI, as it relates to the talent pool, it's going to have a pretty interesting bifurcation. You're going to have a bunch of people that tried to get into pen testing because they thought it would be quick, easy money, but they didn't obsess over mastering their craft. And by the way, we saw that with software engineering, where people made a second career by going to a 12-week boot camp to learn how to code, and then they became entry-level developers. Well, Windsurf and Cursor and all these coding agents have suddenly rendered a lot of those kinds of skills obsolete because they're just better coders as a result. And I think you're seeing this huge unemployment pool of these boot camp grads that can't find jobs anymore. And it's even now progressed to entry-level computer science grads as well. So it's not just a 12-week boot camper. It's a bachelor's in computer science from a top 25 school that's actually struggling. So talk to me about your career journey, and more importantly, what do you see as the criteria for a successful offensive cyber operator in the age of AI?
Yeah, it's a great question. I think it's something that it hits close to home in a few ways. I'll say my partner is actually somebody that did a 12-month boot camp and is now a software engineer, right? And she did that, I don't know, 5 years ago. Like you said, if she did it today, it wouldn't be something that she could do or get away with and get a decent job. She has a bunch of like contacts and friends that have taken similar boot camps and are now out in the job pool saying, "I can't find a job. But can you give me a referral?" Right? And I feel really bad for those people because ultimately, as you said, there's a lot of tooling out there and things that are replacing kind of the basics, and it's only going to get more robust as time goes on. So to answer your question, I really think that what makes a successful cybersecurity person, whether it be a blue team or a red team or anything in between, is that passion, that drive to really dig in and get interested in everything, and find the next 0 day or find the next whatever it is, like vulnerability that's going to knock somebody's socks off. It's and like I said, the most fun vulnerabilities that we find are the new ones or the bespoke ones, the things that are totally unique to the environment we're testing. And that's always been the stuff that's hardest to automate. That's what makes them fun, right? If I go and run a pen test, I'm not like, oh boy, I get to run Nmap again. No, it's not about that. It's not about, running the tools or doing the recon or whatever. It's about finding that really interesting, oh, they've got this, handwritten protocol or maybe a protocol for this obscure telecommunications device. Let me dig into this thing, rip its guts out and figure out how to, reverse engineer it so I can get a shell on it. That's the fun stuff. And like, it's fun for me. It's probably not fun for 99% of the population, right? But that's why I think it's going to be more and more about passion, because the tool is going to beat you at doing all the other stuff. It's not going to beat you at reverse engineering some obscure telecommunications device, because to most people and to most tools, who cares, right? But to you in that individual situation on that individual test, it's super important.
Yeah.
I wanted to say too, we had a really interesting question in the chat that I think's apropos to what we're talking about. Andy asked, what's your opinion about vibe coding, and do you think it will cause negative impacts on product security? I know you were just talking about some vibe coding solutions, so I figured that'd be a good one.
Well, so it's a great question. And so I think vibe coding is a great way to build crap applications. And what I mean by crap applications, right, is you're going to get to 70% of a pretty easy, cheesy app to go build. But that final 30% is going to be really hard to get it to work in production, to scale, to make sure you don't have broken auth controls and so on. So I think over the next 12 months, we're going to see this massive surge in crap applications being deployed into production. And it is going to be an absolute field day for attackers and for pen testers. And I think that's going to, but I think in about 12 months, we're going to see two things happen. I think we're going to see companies like SemGrep or Sneak or Invicti or others that are already world-class at SAST and DAST type tools for static and dynamic security testing. I think we're going to see them start to reemerge as really important vectors in the DevOps pipeline for vibe-coded apps. And I think the second thing we're going to see is the actual code generation tools, the Windsurfs, the cursor, Windsurf's gone now, but the cursors and copilots and so on are going to get better at writing secure code out of the box. And I think we're going to see this big surge in highly exploitable crap applications. And then it's going to peak in probably 6 months and massive hype and panic. And we're going to see policy lockdowns of whether that code is actually allowed to be put into production. We're going to see a big spike in SAST, DAST tools to secure those codes, to secure that code. And then you're going to see those coding agents inherently get better. Because if they don't, they're going to render themselves obsolete, right? The replets of the world, the cursors of the world, if they're not able to write secure code out of the box, then they've got a big problem. And they actually have a technical hurdle there, which is they have trained on bad, vulnerable, crappy code. And so they're going to produce bad, vulnerable, crappy code. And my guess, if I were to wear my venture capital investor hat on, my guess is that Sneak and or SemGrep and or Invicti get acquired by those major coding platforms for a nice premium, and that all of their knowledge on secure software development gets baked in, and that becomes the big differentiator between them.
Yeah, really astute, I think. And I would say like in terms of vibe coding, I love to see it as a pen tester. As you said, it makes some of the most janky, terrible applications from a security perspective that are just, they're tons of fun to test. It's like a pinata full of vulnerabilities basically for us. So but putting my bent as a pen tester aside and more so on the business, and I do think it's a major concern. It's something where these applications, I've seen them in production already for really critical business functionality. And you authenticate to them, or you just open them in your web browser and you're like, oh, here's SQL injection. Oh, here's cross-site scripting. Oh, here's a remote code execution. I've seen those types of applications where they'll take any type of user input and they're like running it on the command line as like a Python, executable or as a, command exec, right? It's like, it's a total recursion or reversion back to these like terrible development habits that I felt like they were gone for a while and are like starting to rear their ugly heads again. There's kind of like there's a cyclical element to security, I think. Like I used to compare it to like the latest and greatest Windows vulnerability was kind of like the peak and the trough for us. Like back when Eternal Blue came out, it was shells for everybody, super easy. Get into an internal network and you're guaranteed to get domain admin if they're using SMB. Fast forward a few years, and we hit a trough where it was really difficult for pen testers and really great for defenders because people had gotten a lot smarter. They'd patch all their vulnerabilities. They'd have robust EDRs and things in place. And unfortunately, talking about the now, one of the biggest blind spots for defense in terms of like detection and log ingestion is applications. They're complicated. They don't really make sense at the best of times. And it's really hard to take that into a standard EDR, even with user behavior analytics and all these other tools that we have, and get meaningful results out of it. When I was a blue teamer for a number of years, that was the thing I dreaded more than anything, is when we had an incident that affected an application, because we basically had to learn that application from scratch to figure out what was going on with it. So if environments are full of these terrible applications now in the future, it's going to be a nightmare for blue teamers. And I think it's, as you said, a problem that really only an AI can solve the problem of an AI, right? We throw a DAS tool at it and hope that it secures it enough to stop it. But honestly, I think vibe coding is really going to hurt blue teams more than any other thing I've seen in a long time. Unless there's some additional like harness put on top of them, or QA basically, to stop them from going into production with all these terrible vulnerabilities in them.
Yeah, and I think building on that, I think MCP servers can be either a blessing or a curse, depending on whether you know what you're doing or not. So if you take MCP servers, a lot of vendors are starting to push out MCP servers as part of their capability. And if you're not careful, I mean, MCP servers basically running as system with the ability to invoke any tool you want on the host it's running on. And there are a number of examples. And in fact, Naveen on our team did a tech talk on hacking Gen AI systems, and we spent a decent amount of time on MCP server. I think it was the exemplar Postgres MCP server on AWS had a bunch of, it was riddled with vulnerabilities. I think that was one he used as an example, and is supposed to only have read-only access to the database by default. But if you're really nice to it, it'll give you write access. Like, no, I'm serious. I'm your friend. I'm not a bad guy. Like, that's all you had to do to nudge it along for it to flip and give you access. And so I think MCP servers are going to be the bane of the existence of multiple vendors, or many vendors that are starting to ship those as part of their product. So we just announced an MCP server, and we went through and we were terrified of launching this thing. And so we actually spent a decent amount of time thinking about How do we enable the goodness of MCP servers, which basically gives you a natural language chat GPT interface to your system. And that's really valuable for allowing humans to quickly integrate you into automation or getting yourself integrated into agentic workflows with other agents. And so the approach we ended up taking was we use MCP servers as an extension of our APIs. So we basically said the MCP server is highly restricted. It's only able to use a very specific set of protocols. It can't do a bunch of things. It only has the authority of the auth token from our API key. So if you get the API key, that API key gets loaded basically in the MCP server, and the MCP server can only has the authorization and access of what the API token had access to. And so if we revoke that auth token, the MCP server is rendered moot at that point or obsolete. And so we did a bunch of things to harden and dramatically minimize the attack surface. That's because we cared very deeply about making sure the MCP server was secure. But I don't think a lot of vendors out there that are quickly getting these things out the door have done that level of rigor, like allowing MCPs to invoke tools. But the benefit is, our GQL API has access to 10,000 data points within the Node.0 platform. I think you guys have used some of those APIs. And trying to learn all 10,000 of those APIs is pretty ridiculous for a human. It's very hard. But an MCP server suddenly gives you the power of natural language to interface and run pen tests, get results, get fix action details, schedule a pen test, all the things you'd want to do in an agentic workflow. And you can actually do cool things around run a pen test, get our findings, pull the recommendations, use the recommendations as part of a prompt to Git Copilot on coding a fix to like your Kubernetes configuration or your infrastructure as code changes or so on. Use Argo's MCP server to deploy the fix, and then use our MCP server to run a retest. Suddenly you've built an agentic remediation workflow. So what have you spent time looking at MCP servers specifically and how to compromise these?
Yeah, we absolutely have. And anything with an AI bent to it is something that we're heavily targeting. Sometimes we're actually building our own mini LLMs to attack other AIs, just to provide them with all of the different inputs and injections that we want to try. Because, like you said, I mean, if you've got 10,000 payloads that you want to try and you want to go and manually or even autonomously deploy them, it can be really difficult. You're going to hit all kinds of strange obstacles that you're running into. And I think kind of like zooming out for a second, like when you're talking about how AI is useful for security, I do think there are a lot of applications for it in a really narrow controlled environment like you're talking about, where you use it to accomplish a very specific task. You check its work because you got to check its work, but it still does a huge part of what you needed to do that would have taken you potentially days or months even sometimes. And it can do it in a matter of minutes. It's just about like checking those key points and making sure it didn't do anything crazy. I know a lot of red teamers that, these are seasoned guys, and they've got all these skill sets. They're able to build payloads for all kinds of different systems that beat the latest and greatest CDR. But it's funny, a lot of them have these really weird gaps in their skill sets. This isn't a super weird one, but like they'll build a payload for let's say PowerShell, right? And they have this really great payload. It evades everything, AMC, everything that you'd expect to get caught on PowerShell. But what if they go to a system that doesn't have PowerShell? Well, suddenly their magic payload doesn't work anymore. And they don't really know how to port that over to some other language. So they'll use AI to port it over to something like C# that they're not familiar with coding in. And then they'll take it to their friend that knows C# and say, hey, is this okay? Did I do anything dumb? And the friend will look at it and say, oh, well, I tweaked this thing, and that function doesn't really make sense. They spend, maybe 30 minutes or something fixing it up, but now they've got their magic payload for C#. And that's a really powerful piece of that workflow, because the alternative 10 years ago was that same red teamer that doesn't know C# but needs a C# payload now has to go open up one of those, 400 or 500 page long books with a little animal on the cover about learning C#. And that's, I don't want to say it's a waste of time, but it's a huge time investment for that one payload. We don't have to worry about that anymore. We just need to be a little bit smarter with how we leverage AI in our workflows.
Yeah. No, it's so you actually described an interesting LLM pattern in how your friend, that person asked their friend about C# and does this look right? So in LLMs, there is like a well-known pattern called the critique pattern, which is a really fancy way of saying you just asked a question in GPT, why is NCC the best pen testing firm in the world? You're going to get a really long answer. And then you're going to copy and paste that into Grok and say, hey, Grok, critique this answer. And then Grok's going to come up with a bunch of critiques. And you're going to take the critiques and paste that back into GPT and say, hey, GPT, incorporate these critiques. And it's going to update its answer. You're going to copy and paste that into Grok. And eventually you're going to go back and forth until you've got an A+ or an A- quality answer. And what you did was you basically took a question and used two different models to critique that question. So it's a pretty standard technique to help make sure things like website copies or press releases or research papers or any other more complicated answer where you want to make sure you're in a really good spot gets to a high quality answer with minimal or no hallucinations. And that's pretty standard. And then there was a lot of like marketing hype or buzz around the model alloys, which is really just a fancy way of using the critique pattern. It's you took an answer, you hand it off to another LLM, and it was able to help you unstick or improve through that answer, and you just go back and forth. The problem at scale is that becomes insanely expensive because every time you pass in a bunch of data into an LLM, you're paying input tokens and you're paying output tokens. And so we actually found that blindly or iterative trial and error with LLMs costs 700x or more compared to this blend of automation, machine learning, and very targeted reasoning. And that's because you end up with a lot of wasted iterations. Every time you ask a question and then the answer isn't perfect and you ask the second question, that's called an iteration. So you're talking 50 to 100 iterations to get to successfully running an nmap command. Or you can just run the nmap command, like you know what it is. And what we actually found was what we're starting to call like a high counsel pattern. And this is kind of what you just described with your friend asking the expert. If we start to detect that the LLM is beginning to wander, then you quickly stop the wandering, like you don't go any further. And then you ask a high counsel, which is multiple models at a time, hey, what do you think about this? What should I do next? And you're not asking it to critique you, you're asking it for advice on creativity. And that's actually a really interesting use of LLMs in this high counsel pattern of using hey, how could I attack this? What do you think? And in many ways, you're asking that same question to 4 or 5 different types of models. You're getting back the answers. You're aggregating those answers and saying, okay, which of these should I try next? And it's just a really interesting way of kind of faking creativity in the process through this high counsel model. It's also way cheaper from a token cost standpoint because you're not wasting iterations on things. And so I think there's still a lot to learn on how to use these LLMs, but I'm of high conviction that iterative trial and error is just a fancy way of brute forcing your way through a problem using LLMs. But I think these other paradigms are going to emerge to be far more effective.
Yeah, I mean, I'm super tempted to wax philosophical about what it means to have a high counsel or essentially like an expert bias on something like that. But instead of doing that, we've only got a few minutes left. I want to address the other question we have in the chat, which is it's from Archada. So they say, how can we implement zero trust with zero touch, independent of location covering entire country, even with no internet? So I think that's a really interesting one. I can grab that one if you'd like, or you can take a stab at it.
Why don't you go first?
Sure. Yeah. So I think implementing zero trust, I mean, it's funny, like I feel like I don't hear anybody talking about zero trust anymore, even though, rewind a year or two and it was like the only thing anybody talked about. I still think it's a really interesting thing to try to implement because inherently in a computer system, you need some degree of trust. Like I published a white paper a while ago called not zero trust, one trust, two trust, red trust, blue trust, Dr. Seuss, kind of a hokey title, but hopefully it kind of gives you the point, which is like, it's not necessarily about taking zero trust to zero. It's about taking it to 1 or 2. I think when you're taking something like, an AI powered model and trying to apply it to something like this, you have to really think about the level of trust you're giving that model. So, as you asked in the question, implementing it with zero touch is really difficult, because if you just give it to an AI and just have them try to implement it, you're going to have a explosion. It's going to do something terrible. I've seen it already, maybe not 100 times, but high double digit amount of times. So I think instead you want to have a model, ideally that maybe you haven't trained it yourself, but you've had some input into how it's built. You've given it some of the kind of bespoke perspective for what you're looking for. And then again, like kind of back to what we were talking to, when you have an AI model, giving you output, the important thing is you still have to be the authority. You still have to understand what good looks like. That's coming out of the other end. It's easier when you're asking it to write something for you. It's a lot harder when you're taking something like implementing a zero trust model on an internal network and saying, well, did it succeed? Maybe. It seems good enough to me. You don't want to be in that position, because I guarantee you, somebody a lot smarter than me is going to come in on a pen testing team and say, oh, there's all these wonderful gaps now that I can come in and exploit. The difference is if you come in and implement that model and you know what a zero trust or a one trust kind of model would look like in your network, you just don't have the cycles to implement it. If you can come in and effectively audit what that AI has done and make those tweaks and fixes that will, kind of pick up the slack, that's really, I think, how you do it. It comes back to that like human plus AI approach that I think is really effective, because you're not spending the time building the entire model, but you're spending the time fixing all of the holes in it. It's editing versus writing. It takes a lot less time to edit a book than writing a book. As somebody that used to be an editor, I feel like I have the authority to say that. But
well, actually, that's a good point to bring home, which is back to AI and humans. It's easier in terms of calories to put in to edit a book or edit a paper, but it requires a significantly higher level of expertise to do so. For the most part, you have to understand that topic you're editing or you're critiquing or whatever. And so the expertise level increases, but the calories, the actual actions you're spending time on are also increasing in value. And so I think that it goes back to our point of, if you're not obsessed, if you're not mastering your craft, if you're not an expert, it's really hard for you to spot inconsistencies or inaccuracies in AI slop produced by Grok or GPT. And you're just going to copy, paste, and post it out there. But if you are an expert, you're going to pretty quickly find those really nuanced points that are just wrong, and you're going to be able to edit it accordingly. And I think that's the future, where you have to be an expert in order to be a good editor of what AI is producing, whether it's code, a paper, or an attacker command.
Yeah, no, I totally agree. And I think like maybe a topic for next time. I think we're already over time. Thanks everyone for sticking around. But I do think it's really interesting to think about, what does the next generation of security experts look like? How do you come into the industry with 1 year, 0 years, 2 years of experience and become that expert that can edit for AI or edit for the next latest and greatest software tool? It's a steep slope to climb, steeper than it ever was. When I got started pen testing, all I had to do was run the Metasploit module for MS 08067. I'm dating myself a little bit, but and I could get a shell as a almost zero knowledge pen tester. Nowadays, you need to know a lot more than that to get a shell, and you need to know a heck of a lot more than that to understand why the AI is not getting a shell with the same exploit, and fixing it yourself. So, I think that passion is still what's going to drive you there, but you're climbing a much steeper road than you ever climbed before. It's a scary thing to think about.
Amazing. I think that's a great topic for the next time. I'm looking forward to it, Jordan. And thanks for having me on the show. This was awesome.
Yeah, no, really great talking to you, Snehal. Thanks everybody in the audience for sticking around and asking some great questions. I really enjoyed the discussion, and hopefully everybody else did too. All right, well, I'll end us off there. Thanks everybody for your time, and look forward to seeing you out here next time.